Welcome back. This is A-level computer science 9618 paper 4, and today in this video we are going to understand about graphs and dictionary. We're going to cover graphs, we're going to cover dictionary, and we're going to cover stack and queue. Okay, stack and queue, we're going to understand the code we will run in the computer, but for now let's discuss about graph and dictionary. Graph is, there is no coding for graph. It's not you don't have to write any kind of a code in graph. Whereas for dictionary, it might be possible to write a code, or you could just write a pseudocode for this. Let's start from graph. How do we create graphs? Graphs consist of nodes and vertices. These are nodes and these are vertices which are connecting to one another. Okay, so a graph which doesn't contain any kind of a direction is known as undirected graph. Okay, and a graph which contains any directions, like for example, it contains any, if I just copy this and like it contains these directions, then you can call it directed graphs. Okay, so if we have undirected graph, we can represent them through a matrix like this, in this way. Okay, like for example, A and B having a vertex, so it's 1, A and C containing a vertex, so it's 1, like this. Okay, so you're representing in a form of matrices. Same thing here, in a form of matrices. Okay, C is coming to itself, so C is 1, and A and B, there are 3 vertices, so A and B 3, B and A 3. Okay, like this. So these are undirected graph. But what about directed graphs? We can represent like this. We can just say that vertex A has these adjacent vertices, vertex B has these adjacent vertices. So this is how you try to represent in directed graphs. So this is graph. Okay, then we have, and the reason why we use graphs is we try to, for example, the Dijkstra's algorithm, A star's algorithm, which we discuss, this is where this is where graph is mostly used. These are nodes and we have this cost. Okay, and we need to find the shortest path. This is the example, this is the application for graphs. Dictionary consists of a pair of key and a value, where the key is used to find the value. Okay, each key can only appear once, and some same value may appear more than once. Dictionary, so in a dictionary, every value will contain a key. Okay, and that key will be used to find that value. So this is in Java and this is in pseudocode. In pseudocode, it's something like this, that you're trying to create a type, a record, type dictionary entry, declare key, integer, declare value, string, declare my dictionary array of this of dictionary entry. This is in pseudocode, but as for this is in coding, and we are using a hash table for this. Okay, dictionary, integer, string, student dictionary is a new hash table, and then you just putting it, the values. This is the value, this is the key, and this is a string. Okay, corresponding to this. So this is dictionary. And let me just write down the code. Let me run this code in my computer, and we will discuss stack and queue as well. Okay, so let's discuss about dictionary, and this is the code. We all know that if we just create a key, and according to that key we create a string, and if we put the key back, then we will get that. Let me just run this. I will get Leon. If I put 27, if I put 56, I will get Kennedy. This is dictionary. Okay, I have used a hash table, integer, string. This is an array list. Okay, object is a new hash table, and this is how you create a dictionary in Java. Now let's come to sorting. Let's come to stack and queue. Let's discuss about stack. Inside the stack we have push and pop. Push means inserting into the stack, and pop means removing from the stack. What is stack? Let me show you. So stack basically is let me just okay. So this is how. Supposing we have these two rectangles. This one is a stack. Okay, this one is a stack. And the other is a queue. Let's suppose I put 56, then 78, and then 23, and 678. Push means inserting into the stack one after the another, like a mountain. It's becoming like a mountain. Okay, and if you want to remove a numbers, then you will start from here and insert from here. Because if, for example, you have a pile of books, like 1, 2, 3, and if you remove from here, then everything will collapse. That's why we just start from here. So push and pull and pop. So if you want to do it, if you want to remove, you start from here. This will remove, this will remove, this will remove, and this is how it is. So first in, last out. Okay, first in, last out. This, on the other hand, if you put something, it will. Okay, we try to imagine that the number is increasing from here. Like it's starting from here, 0, 1 through 3, 4, 5, 6, 7. Okay, and in the queue it starts from here, just to give an idea. I put another number, 34, and if I remove a number, then it will be removed from here. So this is FIFO, first in, first out. This is queue. You are on a queue line, right? This is a guy who's giving you samosa and roll, and I'm the first person. I have take the roll and get out from there, and then the other one comes into my place. This is FIFO. This is first in, first out. This is a queue. Okay, you're inserting, and whenever you need to remove, it's removed from here, and then these will shift. Okay, let me show you in the code. So if I run this, let's say I want to run queue only. If I run this, I'll get this. Okay, 56, 78, 23, 670. Okay, I have created a 10 length of this array, and I can see that I got 6 space left. And if I s1 dot push, f1 dot pop. If I do s1 dot pop, what does it mean? Okay, so if you do pop, it will be, this one will be deleted because first in, last out. Okay, and if I keep on doing this, and everything will be deleted like that. Let's do it one more time. I've done 3 times pop, so now 56 left. Okay, pop, 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 56 left. If I just put something again, 786, I will get like this. Now let's discuss the code of a stack. First of all, I have created an array. I got the pointer -1, I got the size, and I have called the constructor to initialize the size and create the array as well. After creating this, I got the push function. It's saying also, if I try to fill this up and if I add one more time, then it will say stack is full. Okay, throw new stack overflow error. Throw, that's why throw is very important. It will throw the error. Okay, Is full is a boolean function that will check if ptr is equals to size and return true, else return false. If it is false, then this will not run it. R plus plus ptr, which means this is incremented first and then we have put in a value. That's why it's increasing like that. Okay. Then we got the pop. If it is empty, it will just throw empty stack, and I've just put a 0 and then it will decrement and it will return something even though it shouldn't return something. I think I should just remove this public void and it won't return anything. Is empty, that you will check that if ptr is equals to -1, then return true, otherwise return false. You can get the size by ptr plus 1, and this is how you create stack. Stack is so easy, very easy concept. No, there's nothing to be afraid of. And if you just remove all of this and you want to see whether it's working or not, then it is working. But if you put s1.pop, now it's a void, it won't return anything. Then it will just remove 678 is being popped out from the stack, 788 is inserted into the stack, pushed into the stack. So this is stack. Okay, now I'm going to remove this. I'm going to start with q. q1 p1 is equals to new q. I'm just inputting something, and if I run this, I will get this. Now let's add another one. Dot in q 67, another one, dot in q, and I'll get 30 through 345. Now let's see. Okay, now I want to dequeue it. So if I dequeue it, what will happen? If I dequeue this, if I do this, this will remove this number. This value will remove first, and then this will come into this place, this will come into his place, this will come into his place. These values will be shifted to the left after this one is gone. Okay, so this is first in, first out, first out, first out, first in, first out. Let me just run this. So you can see here 12 is gone. This is how you're doing dequeue in q. This is how q is working. I will show you the code, but let me just check this again, and I think it's working perfectly. Let's see the code here. So I've just initialized front and rear. Front means the front, rear is the pointers going down and going right and left depending on when you're inserting a value. If front is -1, q is empty. Okay, right, but before that I just called the constructor and I just created an array of size this. If front is -1, the q is empty, q front. In q, now we do in q. If front is -1, rear is -1, plus plus front, so front is incremented and rear is also incremented. Okay, else if front is equal to 0 and size is -1, sim.print and q is full, else r plus plus rear. Yes, so wait, if okay, if this is the start of the queue, then this will run. Else if it is full, then nothing will happen. Else this is the middle one, like in the middle it's been from the start I've just initialized, I've just incremented front, and then in the middle I've just start using this, playing with rear only. Maybe I don't need a front, maybe I don't need it, but I just put it in. I can remove that. So if I just put, I can remove front, though I don't need a front to be honest, but still it works, still can work. Okay, dequeue is if rear is equals to -1, which means if it is empty, the queue is empty. stack in queue is quite similar. That's why I've just done a copy paste. So 4. Okay. This is very important. I don't know about the other. I mean, I do know about the other. They are all very easy, but this one is a little bit tricky. And after that, queue is complete. Okay, so let me show you what this is code says. Let me just show you. Now dequeue means that you are deleting this. Okay, if rear is equals to -1, queue is empty. Okay, done. But after deleting this, you want these values to be shifted to the left. This is coming to this one is coming in here, 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 this one is coming here. You are shifting it to the left. So should I do this? Int I is equal to 0, I is less than equal to rear -1. I have just done a -1 in here. Okay, Ri is equal to Ri plus 1. So Ri is equal to Ri plus 1, which means that you are shifting it to the left. This is why you use this. And at the end you put rear is equals to 0, and then you just decremented rear. Okay, using this I'm shifting it to the left, and also rear at the end after it's done, rear the end value would be 0, and rear minus will decrement because I've just deleted of an element. That's why I've done this. So this is stack and queue. Okay, this is how it's working. Nothing is there. Stack and queue, it's all done about linked list, and we're going to cover binary tree as well. So right here I've just created an object of linked list. Okay, so I've created a node. Okay, so what is a linked list? Let me start from there. Linked list is dynamic, which means it doesn't have a fixed limit. Right now you guys are studying linked list through an array. Okay, that you have created an array, and then you're just converting this array into form of linked list. But this is not linked list actually. Linked list is dynamic, and dynamic means that it doesn't have a limit. So for example, I have created a node. Okay, so this is my node. It contains a data, and it contains a pointer to point to the next node. So I'm keep on creating this node, and it's keep on pointing to the next node, and to the next, and to the next. It keeps on going. This is dynamic, and it's connecting to one another like a chain. Okay, so this is a linked list because it is dynamic. It doesn't have a fixed limit. Right now what you guys are learning is through just using an array. Maybe they just want you to break it down slowly, but this is what you're going to learn in the university, or when you're when you decide to learn it for yourself, because you're just going to create an object and you're going to use this. Let me show you how it is working. Well, first of all, I'm going to put some values in it. So I've created this an object, and I wanted to put some values. So insert 55 for 44. Okay, L1 dot insert, let's say 23. Again, L1 dot insert, I got 66. Now I'm going to print this. Print if there is a print. Okay, there is a print. If I run this, what will I get? This is my linked list. Okay, or maybe I should just show you guys in a better way, like instead of this it should be like, okay, so this is a linked list. You're just pointing to the next value, and then this value is pointing to the next value. It's a complete chain. Okay, supposing if I wanted to delete something, L1 dot delete or remove, there you go. If I want to delete 23, I will delete 23. After deleting this, okay, before that let me put another value. Insert okay, insert 102, and or let's say, and you know what, let me just delete 88. let me show you the print 2 times. So I got this. It was this, it was okay, out of index. Okay, so I need to put an index. Sorry about that. 0 1 2. I want to remove this. So I've just okay. So if I wanted to remove, let's say, index number 2, 0 1 2, and this is how you have I just remove this. Okay, insert, remove, find is very easy. So this is linked list. You just dynamically, you can create as many linked lists, as many node as you can. You can input so many numbers. It could go infinitely depending on your size of the memory. So this is linked list. Okay, now let's discuss the code of the linked list. So first of all, what I have done here, I have just created a node. This node contains the data in the next node, the next pointer. Then I've created a class. I have so many things, but don't worry about it. Next pointer, this pointer, that pointer. I think you don't need to worry about it. Insert. How is this code happening? Let me explain it to you. First of all, I have created. First of all, I get a value. Let's say 50. Let's say 44. After getting a value, I have created a node. A node. I'm using this class. The node. It's on. It's above. Node is the class. The node is equals to new node. I've created a node, but it's completely empty, doesn't pointing to anything, doesn't have data. I've created this. The node dot data is equals to a. I've put some data. The node dot next node is null. Right now this ptr is null. Okay, if head is equals to null, if it is a new, if you are creating a new linked list, if the head is definitely null, if there's no head pointer, then you're going to initialize the head pointer. Then this will be like this. Okay, head pointer. Else, if the head pointer is not null, if there are more than two, if there are more than one values, okay, if there was initially one value only, then you just put the, you're going to initialize the head. But if there's more than one value, if there's already exists a value and this is a second value which is going to become, then you're going to the else part, and then you're going to use temp is equal to head. You're going to take, you're going to take the head. While temp dot next node is not equal to null, because these are connected like these, and this pointer is pointing to null. This is known as the end of linked list. End of list is pointing to null. Okay, while temp dot next node is not equal to null, temp is equal to temp dot next node. So it's shifting the memory and saving it to here. So this is how you can say it's keep on going. Okay, temp is equals to temp dot next node. Temp dot next node, it's pointing to the memory. Each node has a memory, it's pointing to the memory. Okay, this is how it's been pointing it to. For example, you have this node, it is pointing to the memory of this node, and then this node is pointing to the memory of this node is pointing to the memory of this node. Okay, so if this is saying that temp is equal to temp dot next node, which means this memory is being saved into the temp, and then you can say it's been shifted to here. Okay, temp is a temp dot next node shifted to here, temp is a temp dot next node shifted to here, temp dot next. Okay, after reaching to the end, after reaching here, like this is the one which we wanted, like at the end there is, it's pointing to null, we have reached here. Temp dot next node is equal to the node. Now the node will come, the new node that we have created, this will come here. Okay, and so this will pointing to this node, and then this node will point to null. Okay, temp is a temp dot next node, and then the node that we create is pointing to null anyway. So this is how you're inserting into the linked list. You have created a chain. You start from here, this is the head. Okay, getting a temp, temp is storing the memory by taking from the head. Then temp is equal to temp dot next node, temp is equal to temp dot next node, temp is equal to temp dot next node, while next node is equal while it is not equal to null. This is not equal to, actually this is pointing to null. After reaching here, you just then temp dot next node is equal to the node. Now the node comes, and now this one is pointing to null. Okay, this is how you insert into a linked list. At the same time, at the same way, you can delete it as well. So this is how you insert in a linked list. Insert count, don't worry, it's very easy. You can see this the code anyway. Temp dot head, I've just taken head, while temp is not equal to null. Why it is not equal to null? It will just keep on counting in, and it will keep on going to the next. The number of nodes are lame. This is how I've created a count. Remove means delete in a delete a node in a linked list. How is this happening? Okay, let me just now. Okay, wait. Okay, supposing I want to remove this is my linked list. Tab is equals to head. I've taken the memory, the stored inside head, so I've taken it. This is our head pointer, head ptr. While time is not equal to null, now right now I'm just taking a count. Actually I'm doing this through through index. Now if I put a value, I can easily delete this. Okay, but I've just done it in a different way, finding it and then deleting it. You can do it either way, don't worry. You can just either do it through an index, or you can just find a value and then delete it. Okay, I've just used an index. So I've taken a count, and if p is greater than limit out of index, try again, else. Okay, this is the main part. This is the step that you need to understand. I put a loop, and according to this index, I'll just previous ptr. Okay, there are two things. For example, if I wanted to delete this node, I wanted to delete this. Okay, or yeah, I want to delete this, so I need a pre pointer and then also a temp. I need a pre ptr and I need a forward ptr, or you can say I need a temp variable, these two variables node. Okay, pre ptr is equal to temp, because I've just in pre ptr is pointing to this. Temp is equal to temp dot next node, it comes here. Now it's pointing to this, temp is pointing to this, pre ptr is pointing to this. Now for example, I wanted to delete this. Okay, I wanted to delete this. So pre ptr, okay, this is the main part. This is the main part. Okay, pre ptr dot next node is equals to temp dot next node, which means this is not this pre-ptr, this is pointing to this instead of this. This is pointing to this. Okay, and I'm going to say that time dot next node is equals to null, and there you go, it's deleted. It's very easy. For example, you have these nodes. Here's what you're going to do. You're going to tell this node that you're going to point this one instead of this, and this will be point to null, and that's it. This is how you delete it. Gone. That's it. So this is how I've just used, I've done like this. This is how you delete in a linked list. Okay, and I hope you guys understood. Otherwise, I'm going to make another video for the linked list built through an array, which is discussed in the textbook according to your syllabus. Don't worry, but for now, right now, I just showed you how to delete this. Okay, this is how I've deleted. Let's move on. And that's it. Print this print times the time dot next node. This is a golden statement. You need to understand why it is happening. Okay, if you understood this and you understood this, then I can guarantee you guys that you have understood linked list completely. Okay, and also you need to understand this, that we are creating a node, creating a memory, and then you just connect it to one another by storing their memory. So this is actually a true linked list looks like, not some array with an array and have some limitations like you need to initialize the length of the array. No, they're just teaching you guys just to make sure that you understand what actually linked list is. But this is the main concept. Some of these I've just made some concept myself, but the actually true concept is that you are creating a node and then you're just storing the memory of that node, and these nodes are connected to one another by storing their memory address. So this is how linked list is created. Let's come to binary tree. This is our binary tree, and this is also very easy. Let me run this. If I wanted to, okay, let me show you how it is being made. Okay, we know what is a binary tree. All right, if for example you have the number for 55 is the main, anything less than 55 is going to the left, anything greater than is going to the right. So if I say 55 and then I got 35, then it will come to the, it could come to the left. Again, 12 less than come to the left. 15 less than greater than, it will come here. 78 greater than, it's greater than 70, it will come here. Okay. $66 greater than, less than, this will come here. 120 greater than, this will come here. And this is how I have created a binary tree. Okay, and the way I've done in order means that looks like I need to check this. How did I do it? But actually this is not part of your, you don't need to do this. You can just directly, since you guys are doing with array, you can just directly do print. Okay, you don't need to do this. I'm just doing this just to teach you how it is working. So this is how my binary tree looks like. So yeah, okay, another thing, that these binary tree, these are nodes, just like linked list, that you have a data, you have a left and right. So you have something, that pointing to the left, pointing to the right, left, right, right. In right there is null, pointing to the left it is null, right, pointing to the left, right, it is both null, left, right, both null, left, right, both null. Okay, so this is how you are creating a binary tree. These are nodes. Okay, each node contains a data, it contains a left pointer and a right pointer. Left, right, left, right, left, right, left, right. This is how you create a binary tree. Okay, Let's discuss from here. Okay, let's understand how insert node is working. If root is equal to null, if this is the first binary tree, if the binary tree is being created, if the root itself is a null, the root, what is the root? This is the root node. This is a root node, and then starting from this node, we can create a whole tree. If the root is equals to null, then the node is equals to new node 1. The node dot data root is equals to the node. So I've just said that this is the root. Okay, this is the root node. If data is less than root dot data, it will go to the left. If data is less than root data, it will go to the left. Root dot left is equal to insert node root dot left dot data. I've done recursion in here. This is complete recursion. It's based on recursion. Okay. Okay. If there was any way to put this somewhere else, but I think there's no other way for this. Or maybe there is move actually. Can you move this? Okay. Never mind. So data less than root dot data, root dot left is equals to insert node root dot left and data. Initially what I've just done, I've just put a root and I've put a data. Okay, this is insert node. Okay, let me use a different color, otherwise you guys might get confused. This is the function. So it's returning a node root dot left is equal to insert node root dot left dot data. It comes here. If the data is less than, it comes here. Maybe I think I should just do it from the beginning. Supposing I got this 12, or wait, I think this is the right one. Did I got 12 or got 55? Where is the other one? Something's mess. Oh, sorry. This is the actual thing. Good. So you know what, let me just write it down in a comment and then I'll show you how it is working. 55, 35, 12, 15, 78, 66, 120. Okay, this is it. I'm just going to copy this. I'm going to put in here. There you go. Now let's see what is happening. First of all, I've got 55. Insert node. This is my function, and it's returning a node. If root is equals to null, if I got 55, then I've just created a root node. This is my root node. Then after that, if data is less, okay, I got 35. If data is less than root dot data, root dot left is equal to insert node root dot left dot data. Right now root dot left is null. It's sending null. Root dot left data. So the memory is actually null. So this will work then. If root is equal to null, if this is null, then this will be created. So 35 comes here. Okay, I got another one, 12. If this is less than, okay, this is not null. 12 has been compared to 35. Again, it is less than root dot data. It comes again in here, and I got 12 right here. I got 15, less than, and this one is greater than, data greater than, do root dot write, data, and this would be null, and that says root is equal to null, create this. So comes in here and it's been created. So it just goes like this. You keep on going like this. 78, you got 78, it comes in here. You got 66, 66 will come, 66 is greater than, and this is less than 66, 66 will come in here, 120 will come here. This is how you're creating it. If root is equals to null, else if data is less than root dot data, else if data is greater than root dot data, return root. And also you're going to put a return root as well. Okay, going to return root, because after creating, for example, after creating this, after it is done, after it just done this, right, yeah, return root, it will return, then 12, it going from here, it this, else if this was run, and then it will return root, return, and this will come. So you always put a return whenever you're doing with recursion. Okay, so you're going to put return at the end so that it could return to itself. This is how you're inserting a node into a binary tree. This is how you create this. Okay, so this is insert. This is delete. Okay, it's quite complicated, this one, but I don't think it would be that much complicated. Search node is very easy. I'm not going to discuss that. So let me just, there is a way, short this. Okay, supposing that first of all, let's discuss about what the code is saying. Okay, okay, so right here we have this function. This is our function delete node. You're sending the root and you're sending the data, and it returns a root node. It returns a node because, so that it could just, after deleting this, you have put a return here, just so that it could just return itself. If root is equal to null, return root. Okay, root is equal to null, return root, because if the root isn't created like that. If data is less than root, right now I've just put a data to find that value and delete that node. Okay, so if that data is less than root dot data, for example, let's say I want to delete 66. Right now root dot data is less than root dot data. No, this will be shift. But if data is less than root dot data, then root dot left, delete no root dot left dot data. It's the same thing, same pattern as we have done in insert node. It's the same thing. Else if data is greater than root dot data, yes, 66 is greater than, then it will go right. Okay, if else, and then if root dot left. Okay, so it just keeps on going like this, greater than, less than, greater than, less than, until it reaches here. For example. Okay, so it says that 66 is greater than, it comes in here. This is less than, it comes in here. After coming in here, then this code will be run. If root dot left is null, return root dot right. If you return this, then this will shift in here and this will be deleted automatically. Returning it, which means you just initialize this. For example, 66 was less than 78. This was running, right? That root dot left is equal to delete node root dot. Okay, you can see here root dot left, and after going in here, it says that return root dot right, and root dot right is null. So this will initialize null. Root dot left, this will be initialized to null. So this is how you delete a node. Okay, for example, there are actually three cases. One case is when you are deleting a node which doesn't have any child nodes. Both are null. Okay, if root dot left is equals to null, then root dot right, if root dot right is equal to null, then root dot left. Okay, for example, I want to delete this. Okay, so if root dot left is equals to null, return root dot right. So this will be shifted to here. So this node will be deleted. So like that. So there are three cases. One is when you have both child node to null. Second case is when you have this is not null and this is null. And third case is that you want to delete a node which have a value and it have child as well. For example, I want to delete 78. Now I got both of these. So how will I do that? I'm just going to use successor root dot data is equal to successor root dot right. Okay, root dot right is equal to delete node root dot right root dot data. Now successor is okay. What is a success? After, for example, I want to delete this node and I've just create a function successor. Root dot data is equal to successor root dot right. I'm just going in here, root dot right, if pass in here, and then while our okay, successor means that, for example, successor means that you got the node, it will go right and then it will go left. It keeps on going until it gets a null. Okay, until it gets a null. So something like this. After putting root dot right, it came here, and then while r dot left is not equal to null, num is equals to r dot left dot data, and r is equals to r dot left. Num is equals to, num is the integer, the data, num is the data, num is equals to r dot left dot data at spin, and then return the data while r dot left is not equal to null. Okay, so if I want to delete this, then this will be returned. Okay, and after returning it, after it saves root dot data, so this will be shifted to here. Then root dot right is equal to delete node root dot right root dot data. This will be deleted. This will be shifted to, I mean, this the data is copied to here. This will be 120, and then this will be deleted by calling root dot right is equal to delete node root dot right root dot data. Okay, so this is how you are deleting a node. This is completely out of your syllabus, right? This one, actually this one, I think, or maybe not, but this whole thing is, should be understandable, because this is going through recursion. You're calling itself, and after deleting it, you're just going to put return root. This should be in your head right now. This is how you delete a node. Okay, otherwise, if, for example, because you guys are doing in an array, because this is also connected in array. Okay, like binary tree and linked list are both built with array in your syllabus. That's why it's a little bit different, but this is the main concept on how to create a binary tree and how to create a linked list. So this is how you do a delete node. Okay, then we got the search. It's the same thing, searching for a value. If root is equal to null, sorry, value not found, it's null. What can you do? If it is greater than, then it will just go to the left. If it is less than, it will go to the right. If it is equal to, then you can say value has been found at level plus level. Okay, or if it was an build with array, you could have just um, written the index of that data. So this is binary tree. It's very easy. Linked list and binary tree are both very easy. And don't worry, I'm going to create another video for linked list for the array as well, just so that you could understand more deeply. And thank you so much for watching. I think we have reached the end of this A-level computer science P4. It was amazing for me to make these videos, and it helps me to learn as well.